see the screen and they have a copy of the slides? Okay, great. And the meeting is in the bottom there. So fingers crossed, connection will stay and I won't just be talking to a screen and everyone in the room. Right, thank you very much for inviting me here today. Thank you for the introduction, Tom. It's very kind of you. I'm, as Tom mentioned, Rhona Marsland. I'm a civil engineer working in the engineering and asset management team at the Office of Rail and Road, here to present to you on regulating the effects of climate change. So to start off, I thought the best thing to do would be to split my presentation into three main parts. The first part, talking about the ORR and what we actually do, because believe it or not, a lot of people don't even really understand what we actually do. The second part would be to talk about my specialism, which is earthworks and drainage, and some of the reviews and assurance work that we've been doing in that space in the last year. And then the third part would be to focus more on climate change and what we could do as an industry to improve the way that we record and monitor our improvements when it comes to climate change, or the improving our weather resilience and approach as a response to climate change. So the first part, introduction to the ORR. So the Office of Rail and Road, as the title suggests, we deal with rail as well as road. The roads part, which is shown in blue, is a smaller part of the ORR as a whole. We monitor performance, monitoring road user satisfaction, we secure value for money, or we ensure value for money, and then we also got an advising and assisting role as well. But just to be clear, I know absolutely nothing about roads. That's not my side of the organisation at all. But the orange symbols that you can see there, we keep Britain's railways safe. So I'm sure you'll be well aware of the ORR when it comes to the safety aspect that we have. We hold Network Rail to account to make sure that what they have said they're going to do and spend our money on, our taxpayer money on, they actually do. We protect consumer interests. We ensure that there's clear information about railway funding and their performance. We also regulate HS1 and the Channel Tunnel route. We make sure passengers and passenger and freight train companies have fair access to the network, and we keep the markets under review as well. So this is the main directorates of the ORR. I won't list them off one by one, but the two main ones I want to talk about are the Railway Safety Directorate and the Railway Planning and Performance side of things. So I'm part of the Railway Planning and Performance side. So there's about 80 of us in total. And the engineering and asset management team, there's about 33 full-time equivalents, of which 8 are civil engineers. And in the Railway Safety Directorate, which includes all the railway inspectors, there's about 120. So overall in the ORR, we've got about 300 people. And you can see that a vast amount, 2/3 of them are actually either in the safety side or the railway planning and performance side. So in the railway planning and performance side, there's the engineering and asset management team led by Steve Fletcher. So we have various functions. There's the asset management side of things. There's head of interoperability and railway vehicles. We go right the way through to planning and enhancements, railway control systems, and system costs and efficiency as well for PR23, periodic review 23, which I'll speak about later. But I sit in the civil engineering team, which is led by Dermot Kelly. So there's about 8 of us in the team at the minute. We have various roles. I lead on earthworks and drainage, but I have colleagues that also lead on structures, operational property, tunnels, mining, track, etc., etc. And we've also got a couple of new people in our team, or relatively new people, now looking at on-track machinery and building services. So the main thing that we do in our business day-to-day side of things is we hold Network Rail to account to ensure that they are adhering to the conditions of their network licence. We determine efficient levels of funding, and we also authorise infrastructure under the interoperability regulations, as well as provide special technical advice across ORR. So that would be, for example, to our safety colleagues in RSD. Their inspectors are very, very talented and they've got lots of specialisms, but we also support them when they maybe need a little bit extra help. So I've got this slide up, which unfortunately I couldn't find a more up-to-date version, but I just wanted to illustrate to you the vast amount of sums that Network Rail receive. It's millions, billions of pounds. And as you know, Network Rail is a massive company with hundreds and hundreds of people. And actually, relatively speaking, the ORR is a bit of a bargain. The industry gets quite a lot bang for its buck, in my opinion, for the amount of funding that the ORR get and the services that we provide. So you can see there, like the levels of funding for renewals alone, maintenance as well, huge sums, civils, and of course, I'm particularly interested in earthworks and drainage. So everything I said that we do, the business as usual stuff in our team, all sounds very good, lots of words, but how do we actually do it? How do we actually hold Network Rail to account to make sure that they do the things that they said that they're going to do? So it starts with this pyramid. In the bottom of the pyramid, we've got routine monitoring assessment. That's what takes up, I would say, the bulk of our day-to-day, making sure and doing work with Network Rail to assure ourselves that they're actually doing what they said that they're going to do. If we find that there's an issue, we put it on what's known as the escalator. And as all things, a bit like the naughty step, they would progress up the escalator, and as matters increase in severity, and worst case, they would end up with enforcement action. So that's where there could be potentially fines or enforcement on orders, etc., on Network Rail to make the improvement. Now, that takes quite a lot to get to that point, and we will always advocate for early resolution to get things addressed as quickly as possible. So a lot of my time is spent reviewing Network Rail, addressing any areas of concern that I think there might be in my area of work, doing work to understand it more, and if there's an issue, raise it with Network Rail and hopefully get it resolved as quickly as possible. I like the analogy that we are a critical friend. We're not there to crack the whip. We all want to have a better railway, and we will work in a really collaborative way to ensure that happens. And if anyone wants any more information on that, then there is a document called Holding Network Rail to Account. It's our policy and it's on the ORR website. So you can see in more detail what we actually do to hold Network Rail to account. One of the things that we do is called targeted assurance reviews. So that's where we think, oh, actually, there's something not quite right. There's something that we want to take a deeper dive into, and we do what's known as a targeted assurance review. So we can either do that individually ourselves and say, well, actually, there's something I'm quite interested in. I'd like to go and look at it myself. Or we can do it via what's known as the independent reporter route, where Network Rail also agree that there's something that needs to be looked into. And we go out to the market and procure an independent source. Jointly, Network Rail and ORR work with this independent consultant on this issue and investigate it, reach a conclusion, and then there's recommendations that we agree to be implemented. Or the third option is that if we don't have the expertise in-house, we can employ a consultant to do it. I enjoy the targeted assurance reviews very, very much. I personally like that I can use my expertise and go into Network Rail, request information from them, review it, and come up with recommendations or conclusions and recommendations of my findings. But there's always in the back of my mind, I don't want to be like a kid in a sweet shop, okay? So I can't just decide to pick on every single thing that I think would be interesting. Otherwise, I'd be here forever and ever and ever. So there's some questions and qualifications we've got to have, and we're always tested on, is it actually a real problem? Or is it just a niggle? Is it something that's really fundamentally wrong? Is it worth it? Is it worth my time? And actually, does it even matter? Can we influence it? Would any recommendation that came from me actually help influence and solve the problem, or make the problem or make the solution something that could actually change what's going on? And of course, always in the back of my mind, I'm looking at those two pillars, the two things that I'd said that, 2/3 of the ORR are taken up with the safety side of things and the money side of things, the economic side of things. Is it going to make a difference in terms of cost? And is it going to make a difference in terms of safety? So always at the back of our minds, and I'm always challenged on these things, these qualifications, just to make sure that the work that we're doing is valuable. And I've got some examples on the right-hand side of my slides there, some recent documents that we've published. The first one there you can see is Management of Track Geometry by On-Track Machines. We've just also very, very recently published one on Network Rail's technology adoption, and given some case studies and reviewed how Network Rail adopt technology. And I'm going to speak a little bit more about some other targeted assurance reviews that we've done as well. So every year we do an annual assessment of Network Rail. These are some of the things that were highlighted during last year's annual assessment. And at this very moment, not this very moment, but today I was writing up input into the year that's just been, Network Rail's assessment for the year that's just been, and we'll publish that in the coming months as it's prepared. And that's a really good document. It lets lets the public see how Network Rail are performing against what they said they were going to do, where they're sitting within the control period. Is it what we would have expected? Should they be doing better? Do they acknowledge that, etc., etc.? And then interoperability authorizations. And I wanted to make a special mention here because there's a new station on Monday that's being opened, Reston Station in Scotland, and it would have had to have gone through what's known as an interoperability authorization. So basically ensuring that the piece of infrastructure ensuring that the piece of infrastructure meets the requirements of the interoperability regulations. And Network Rail as an organisation support projects or applicants that are going through this process. There's a link there to document approach to authorisation under the interoperability regulations. So if you are an entity that's building a brand new station or a significant change to a piece of infrastructure, have a look at that link, look at the document and get in touch with the ORR if you think it's relevant. The first station that I authorised with the ORR was Soham Station, which is right down the south of England. But going forward, I should be working with Matt Gillen to help with the authorisations in Scotland. So anyone that's Scotland based, you might start speaking to me more about authorisations in Scotland. So looking to the future. So like I say, a lot of the work that we do is making sure Network Rail are doing what they said they were going to do in CP6, but we've also got Periodic Review 23, or is what's more commonly known in the industry or outside of ORR, is CP7 planning. So what's happening for CP7 and how are Network Rail developing their plans for control period 7. So it feels like we're only really in the middle of CP6, but we're already looking forward into the future. And at the moment, we're just right at this moment in time, we're looking at advice to ministers. So that's advice to the Department for Transport and advice to Transport Scotland on the Network Rail's initial business plans that have been submitted to us. And as we go through the PR23 process, you can see the timeline there. There's lots of milestones, both for Network Rail, DFT and Transport Scotland, as well as ORR, which will ultimately come towards the final determination and what Network Rail will commit to delivering for a set amount of money for CP7. And then we'll start the cycle again and ensure that Network Rail are delivering what they said they were going to deliver. Now we're doing this in parallel with the rail reform and Great British Railways. Acknowledging that there is going to be some change, but we don't know what that is yet. But ultimately the railway is going to need money, so we are progressing with the PR23 process with a gentle eye on what might be happening with Great British Railways. Lovely. So that was part 1 of my presentation. Whistle stop tour of the ORR, and you're feel free to ask me any questions when we finish. I'll just escape and make sure that we're still in the meeting. Yep, and there's no questions. Lovely. Right, back to presenting. So we're on to part 2. So there were 3 targeted assurance reviews that I was part of last financial year. One was around drainage maintenance. One was around Earthworks cost and volume, Earthworks renewal cost and volume transparency, and the final one was around Earthworks drainage and weather resilience. And you can get copies of these reports on our website. They're a riveting read. But the part that I'm going to just slightly touch on is some of the information that we got from the Earthworks and Drainage Weather Resilience Targeted Assurance Review, or TAR. So we spoke to loads of people across the UK. We did it all, of course, during COVID, which meant, unfortunately, we couldn't go in person to see all these people. Maybe it was a good thing that we had to do it all via Teams so that we could actually get such a range of individuals that we could speak to. So they're ranging from people that sit in the centre of Network Rail, so the technical authority, or we were looking at people that were on site in maintenance delivery units. We were looking at route asset engineers, and we also spoke to some people in the supply chain as well. And like I say, it published May last year, so you can feel free to have a look. So some of the examples that we got out of this piece of work, we wanted to understand what Network Rail are actually doing, because they're doing some really, really good things, and we wanted to gather them all up and just find out, what are Network Rail actually doing. So one of the examples is Leeds Flood Alleviation Scheme. So this is a scheme that really captured the fact that Network Rail were considering their neighbours, not just their alignment, but outside of that, and the wider catchment that impacts the railway. So Network Rail contributed about 10% of the total funding towards the Leeds City Council and Environment Agency project. Flood barriers were installed between a river and the railway, and as well as they planted 300,000 new trees, and there was restoration of moorland to capture water further up or away from the railway, but within the water catchment area. And as a result, the scheme meant that the risk of flooding on the railway was reduced from 87% down to 0.5%, with only 10% of the funding that was required for the whole project. So this kind of collaboration really highlights the opportunities that are available to Network Rail and other infrastructure asset owners if they work in collaboration with their neighbours and other organisations to ultimately reach the same goal. Another example would be, of course, the railway is a system, so consider the whole system. So we know that there was the Willesden freight derailment in 2019. Network Rail did a research and development project, and they were able to link earthwork movements to track geometry data. So the data was collected, and lo and behold, it was able to successfully correlate earthworks movements with track issues. And of course, this is just sort of saying, you know, imagine the other possibilities. If we start to look at all the fact that all these different asset types are actually joined up, what information is hidden amongst all that data that we could use successfully. I like to say that civil engineering is the thread that sews the railway together. It's the discipline that joins everything up, it joins the dots. And I think if we think more of that approach when it comes to our data, we can start to really understand how weather or climate change is impacting our assets and what we can do to make them more resilient by looking at the system as a whole. Of course, there's monitoring, and there was loads of examples of monitoring when we went out to speak to individuals and project teams. We found a maintenance team who had used their own initiative. They went and looked out and got local suppliers to install affordable CCTV cameras. So they knew that they had these sites that they couldn't access. They were always having to get to them. They knew there were flood locations. So they sort of didn't wait for the centre to procure a nationwide contract. They went out themselves. They knew there was a problem, and they could install these cameras so that they could use their mobile phones to view these flood locations. And it was a cheaper alternative. It was safer than sending individuals out into these locations, and it was real time. So when we, as an example, we were talking in the team's meeting, they were giving us this example, and the guy pulled out his phone and was like, "Look, I can see right now. I can see what's going on. Isn't this fantastic?" So, again, an example of monitoring the situation, understanding the impact that weather is having on your assets is always going to make you more resilient overall. And similarly, forecasting. So the convective alert tool, you may have heard of it. After Watford in 2016, Network Rail developed a weather alert tool, but it only worked for frontal storms. So that's usually the storms that we have in the winter time, the ones that are visible days in advance. But Carmont, unfortunately, was a convective storm, so a thunderstorm. And for those that are in Glasgow, either online or sitting in this room now, there was a big thunderstorm last night. My garden got absolutely soaked. It only went on for about 5 minutes, but that was a convective thunderstorm. The CAT tool, or CAT, can predict storms that appear 3 hours in advance, so a vast improvement and something that was much needed to Network Rail. Okay, so we can also introduce redundancy into the network. So engineers are very familiar with redundancy and introducing redundancy, but there are some really good opportunities out there, and the Garwin Drainage Renewal Project monopolised on one of those. So they knew that a 300mm diameter pipe wasn't going to be enough for a 1 in 50-year storm. They could have went for a 375mm option, and that would have been 75mm would have been enough to put them into that 1 in 50-year storm event, and they would have ticked the criteria. But actually, they realised that they had the space to install 450mm diameter pipe with deeper catch pits. They also realised that the rest of the network could support that as well. By that I mean there's no point in putting a bigger pipe in if the outfalls and everything that's connected to it are smaller anyway, and it's not going to make much or as much of a difference. So there was extra material cost, true, but that was actually very, very small when you compared it to the labour, plant, design costs and access costs to get there to do it. So now the drainage is suitable for not only 1 in 50, but 1 in 100 and 1 in 200 year storm events. So with a little bit of consideration and thinking ahead, let's just put a bigger pipe in. And then we're on to design reliability. So Somerton Tunnel, there was 30 mil sections of standard drainage pipe in the tunnel with a narrow cess. Instead, they replaced it with 60 metre length, thicker walled pipe instead. This allowed the maintenance crews to jet the pipe more easily from the ends in a safer and quicker manner. So from talking to some of the drainage teams when we were doing this piece of work, they sort of discussed, thin plastic pipes are all very well, but as soon as you start to use the jetting equipment on it, they just crack and snap. And actually the better pipes are the thicker walled pipes. So by putting some design reliability into the project, it means that maintenance crews can jet the pipes easier, and ultimately your asset again is more weather resilient. Design resistance, so Barnhurst soil cutting, so 1.5 kilometres long, 12 metres deep, and over steep cutting on both sides, and a very, very busy commuter line in London. Very old, built in 1895, and there'd been 14 major landslips since then. It was no easy fix. It had to present to several investment panels to ultimately secure quite exceptional amounts of funding to facilitate a full Eurocode 7 design of robust, sheet piles and king post walls. But adding that extra resistance into this project meant that, climate change or future climate change should hopefully be accommodated by a more resistant design. Okay, and then intervention extents. We've got Whitmore landslip. So there was a landslip in 2010, a narrow strip was repaired. Then there was a landslip in 2020, which was next to 2010's landslip. And this kept repeating as well. It kept moving along. And I'm sure geotechnical engineers that are on the call will appreciate this, that you repair one little bit and then the bit next to it fails, etc., etc. So the local team in Network Rail decided to change its policy. So instead of just doing patch repairs, they decided to do the whole 100-metre section. And that wasn't the exception, that was the rule. And if they were to do any less than that, then they would have to consider why they were doing less than that. So in this graphic, you can see 1 to 7 is everything that I've spoke about so far. So those examples are examples of weather resilience, improving your asset portfolio, making it more weather resilient. And it's not just about putting in huge, big, hard engineering solutions. There's lots that can be done to ensure that your assets are more weather resilient. On top of all those things in those examples I gave, there's also asset knowledge, ensuring that you actually really understand what assets you have, where they are, the condition they are, etc. There's also acknowledging the constraints and funding and where it should go, and prioritising some areas over others, as well as risk. And then awareness and implementation. So that's around education. Are you going to have more benefits from educating your staff or personnel on site rather than, again, putting in hard engineering solutions? You could get more of a benefit out of training and improving competence, etc. So all these things that are on the screen here are considered to be 11 weather resilience levers for earthworks and drainage. And they're all things that we identified that Network Rail do and could do more of to improve their weather resilience in the earthworks and drainage space. So the conclusions that we came to split those levers, those 11 levers, into systems, operations, design, and people and decisions. And there's recommendations that we gave to Network Rail that aligned with our conclusions. And the TAR, the Targeted Assurance Review, again, you can find on our website. But very, very briefly, the recommendations were to share your best practice better within Network Rail, so that one team in the south could benefit from the knowledge of a team in Scotland, for example. The second thing was transparency, ensuring that you're telling ORR what your plans are in terms of tackling climate change and weather resilience in a clear manner, for example, using those 11 levers. And the third recommendation was to implement them and not just, I'm trying to think of a diplomatic way to say this. So not just use words, actually act and implement to ensure that proactively your plans can be distributed and there's clear line of sight between the strategies and policies and actually delivering them on the ground. So for example, the drainage team in the Garwin project can clearly see that improving weather resilience links to increasing the diameter of the size of their pipes. Okay, doke. So final and third part of my presentation is around regulating the effects of climate change on weather resilience, a spectrum of practice. So what we did was we took the information that we had gathered from that targeted assurance review, the one on drainage maintenance and the one on Earthworks renewals cost and volume transparency, and published it in an IC journal paper. Alongside that, we developed a model, a scenario model tool that anyone, any infrastructure asset owner could use to understand quantitatively what different scenarios would mean to their asset portfolio. So do we understand what's normal, what we're sitting at right now? Do we know what's achievable and what is best practice? So the model's accessible. It can be used for assessing the risk profile of assets as well as testing assumptions or adding complexity. So we already, if you can input data that you already have, and then you can start to play tunes on it to see compare different scenarios and test different comfort levels. I'll explain a little more detail. So this is the scenario model. It's based on conditional probability. So it's basically saying that weather resilience is the probability that the weather event occurs, and given that the weather's occurred, the assets failed, and given that that failure's occurred, there's an impact on the railway. And that impact might be safety, it might be performance, or it might be cost, or it might be a combination of those three. So if we start on the left-hand side, we can look at the probability of the event occurring. So along the bottom axis, we've got on the left-hand side, ideal weather. That's where you've got your sunglasses on, it's not too hot, not too cold, it's perfect. And then we progress to average, common, adverse, extreme, worst known, and then absolutely unprecedented. So we've got weather in the far left. Then we've got in the middle the probability of a failure if the weather event does actually occur for lots of different asset types. So as we can see, as we progress from ideal weather to unprecedented weather, failure is going to increase for all asset types, but at a slightly different rate depending on what the asset is. And then in the third figure on the right-hand side, again, as we progress from ideal to unprecedented, what's the probability of an impact if there is a failure? So it starts off fairly level, but then it actually decreases. So why would the probability of a failure decrease as the weather became worse? Well, that's because we've done something about it. We have put in, most likely, a speed restriction to reduce the effect of safety, reduce the impact on safety because of the failure. So if we combine those three together, we end up with a portfolio of risk. And we can see for each asset type that when the weather is adverse in the middle, not loving it, the risk is higher probability that you're going to have an impact, and there's less of a probability there's an impact when it's unprecedented weather because it doesn't happen as often. So we have climate change scenarios. So you could start to, like I say, play tunes with this. So you could simulate different scenarios. So for example, you could adjust that weather input A, and just by adding in 20 more days of adverse weather, you can see the impact on your risk portfolio. It peaks up. But if you add in 2 more days of worst known, so even worse than adverse, what does that actually mean to your asset portfolio. So you can see that those 2 worst days that you had isn't actually going to have as much impact as the 20 adverse days, the not as bad as worst known days, for example. And like you can play tunes with various things on it as well. So if we take one of those 4 examples that, or 4 conclusions that had come out of the TAR report, if we just look at systems, we can see the picture on the left. I wanted to choose a Scottish example, the Union Canal breach. You can see that lots of different assets were impacted by it. Track, earthwork, that looks like OLE. Yeah. And obviously there's vegetation and line side impacted by it as well. So this is where the model becomes quite clever, because if drainage fails, then maybe the earthwork will fail, and then maybe a signal will fail, and it all because of just one thing. So you can start to look at the assets individually. So earthwork, drainage, and signal, you can see in the graph to the right, the lower bound values. And then if you add them all together, you actually get the dark black line. But actually, when the system starts interacting, it's even higher because they're all playing off each other. With that becomes opportunities. So you can start to see, well, what's the benefit if I do something about this? So there is a system benefit, and then you can see the benefit of doing something to the drainage, because if you fix the drainage, then the earthwork might not fail. And then if the earthwork wasn't failing, then the signal's not going to fail. So actually, if you can start to target in your system, which asset should I focus on first, which will actually help all the other assets. So basically, our aim would be to give resilience a number, share ideas amongst the industry. So whether it's in with Network Rail as a organisation, but the wider railway industry too. Be transparent on how you're tackling climate change and weather resilience. Use those 11 levers, report on those 11 levers. It's not just about putting in heavy sheet pile walls to stop water flow onto the railway. There's other ways you can do it too, and be quantitative as well about it, and start to use models like this one or other quantitative methods to actually measure what's your baseline in terms of weather resilience right now, what do you aim to be, and how you could improve it too. There's a link there to the paper, but you can Google it, and I searched it last night, and I think that IC have made it free now, so you don't even need to subscribe to the journal to get it. And if you have any questions, you can feel free to email me about it. That's the end of my presentation. I will close down and stop sharing, but I'm happy to take questions. We have some questions in the chat. There we are. And lovely. I'm going to take my mic off.
Thank you, Rhona. Let's see if we have some questions in the chat. Don't. If you have any questions for Rhona. So we'll start with some questions from within the room. Just check, can we have a show of hands to make sure everyone's still awake? I'm sure you are after hearing all that. Yeah. So there's Ron Dempster's still awake, so there's still people online. Okay, so from the floor, we have some questions from Tom Wilson.
deviations that were applied.
It's okay. We're okay now.
It's just because you can, Jim can hear what you're saying.
Okay.
I've put it through your mic, so that's fine.
Okay, so RSSB had a deviation application submitted to them, which they were wanting, something as simple as horizontal and vertical offsets at platforms fixed. And the committee's decision was to do this and this and this, with different actions. And one of those actions was actually just go and install compliant offsets, then you don't need the deviation. What the response to that was, well, if you're going to make me apply for a deviation, I'm not going to apply for a deviation, because if I engage with you and apply for a deviation, there's every likelihood that you'll put the cost up and I'll not be able to do the original action, which was changing the platform crossflow rather than changing the X and Ys. The reason for that was we're not allowed to do even a 20mm track lift. Okay, so you can stack people 9 deep on the platform, absorb that weight on the platform, but you can't do a modest track lift of 20 kilograms per metre run. Oh, it seemed a bit daft. So when we asked for a follow-up to that, the Infrastructure Standards Committee were advised that the applicant had withdrawn their deviation application. So have they decided not to do the work? Is the work going ahead, but just nobody's going to talk about it? So in actual fact, if somebody's disappointed with a deviation application decision, they just run away.
Okay.
And then lift the carpet. So how it's the process is being circumvented, and if people are not liking it, or if the deviation is refused, they don't go away and come back with something else. They just go away.
So I'm not sure I can speak because I'm not informed of that particular example or the relationship with RSSB. I'm not experienced in it. But if are you referring to things like around the interoperability and authorising a project, or just?
Yes, well, interoperability says the NTSN says the standard offset is this and that, horizontal, vertical.
Okay.
When the applicant sees I'm not funded to achieve those offsets because of the workload, then I'm not going to come with a deviation application, because you're going to chase, because not being funded for it isn't the answer. You're supposed to go and get the funding, and if you then still can't get the standard offsets, you're supposed to arrange the funding and maybe do it temporarily, or have a temporary deviation which has an end date.
So again, I can't speak exactly to RSSB, but around interoperability authorizations, there is a legal requirement that new stations and changes in their structure need to be interoperable. Yeah. And ORR's role in that is not that we do any review or any kind of give any opinion on it. We just ensure that the applicant is following the processes that are required of them by the regulations, and that's within the legislation.
So is spot checking?
So there'll be an organisation employed by the applicant to validate, ensure, and issue certificates. They'll review their as-built documents, for example, to ensure that all the NTSNs are adhered to.
But
when we then issue the authorisation letter, we want to do that. The aim is to do it with absolutely no conditions. Mm-hmm. That is always our ultimate goal. We don't want to be authorising something that then has conditions associated with it.
Okay, thanks for that answer. When Network Rail are given by the RAIB improvement advice or improvement requirements, how does the ORR get involved in that to check that an improvement has taken place? Or is that just purely?
Do you mean if there's a RAIB recommendation?
Yes, okay. Recommendation.
So as far as I understand, and I'm sure my RSD colleagues will correct me if I'm wrong, so apologies, but when RAIB issue their report and they provide recommendations, there is a decision between the parties, Network Rail, RAIB and ORR, as to which recommendations will be taken forward, because in some instances it's not appropriate to take through to to implementation some recommendations. Okay, so when they've agreed on what recommendations are going to be implemented, ORR has the responsibility to track Network Rail's progress in those recommendations.
But by way of tracking, do they just ask Network Rail, have you complied with that
We
regulation?
need evidence.
Okay. You mentioned about drainage pipe size. This is maybe more your expertise. I always thought that as you increase the pipe diameter, say from 300 to 450, you introduce the risk of pipe silting. And yet you've only introduced a larger pipe, an expensive larger pipe, for the 1 in 100 year, 200 year event. And that up until that time event happens, that drain with its large diameter pipe is coping in terms of its flow volume, it's dealing with a far reduced flow rate and the potential for the solids to silt out because of that pipe diameter.
So that would be considered within the design part of the project. So the designer would consider that and the capacity of the pipe overall to be able to achieve 1 in 100 or 1 in 200 year floods. So it would be the designer's responsibility. And then thinking of the whole life cycle of the asset, any requirements for jetting would be the maintenance engineer, maintenance team's responsibility. So we'd have to ensure clear handover and understanding between what was put in the design and the maintenance requirements that were needed to ensure that the asset is fit for the weather that it's going to experience.
Okay, so when I hear you say jetting as a response to keeping the pipe unsilted, there were other methods that we used to use in the railway to keep pipes running clearly. When I see pictures of Network Rail's camera run through the pipe system, and I see clear areas where the pipe has collapsed, and I see other clear areas where the pipe is silted, and I then suggest that the drainage engineer or his maintainer goes out to that section of pipe and cleans it out because I want to use it as an outfall to my new drainage system I'm installing. And they say, well, it's up to us to determine what we're going to maintain, not for you to demand that we maintain it clear and running free. And if that outfall doesn't suit you, then go another mile down the track to find a proper outfall on a bit of track that's got 1 in 60 gradient.
Yeah.
You know, so why won't you just fix what you've visibly been told by the pipe survey?
Yeah. I think that would be, if it was me, I would engage with or try to engage with Network Rail as a client and the asset teams. So as we know, Network Rail are there's a delivery side of things and there's the asset management side of things. And whilst the delivery people, the people that are delivering the project, may not fully understand or appreciate the benefits to the system, the asset system as a whole, to do the approach that you've recommended, I'm sure the asset teams would be. So by contacting or discussing it with the asset management teams or the asset engineer, they might sort of realise, oh, yeah, actually, Tom, that's a pretty good idea. If we can change the maintenance regime on this bit of the network, it will help save us.
It's the repair. We've got a lot of places out there which have ancient outfalls to burns and streams up here. And when we go to tie into the existing outfall, then the CCD survey shows the blockages and silted out parts that won't allow us to tie into that system.
Mm-hmm.
So the project are then told, go and find your own outfall because I'm the maintainer and I'm not going to do what you want. Mm-hmm. And that conflict in Network Rail between the delivery organisation and the maintenance organisation is, it's real. Mm-hmm. It's not made up by anyone. And that conflict, it's frustrating for Network Rail project team who would really like to tell the designer, I'll get right on it and I'll tell the maintenance guy, go and fix your work. Mm-hmm. They don't. Or if they do, they're laughed out of town. They say, well, you're the guy with the funding. I've only got my maintenance budget. It would blow my maintenance budget if I went and cleaned that pipe system.
It sounds maybe like the asset management team would be the ones that you would want to speak to. So they're in charge of.
And they say, you're a project, get your own funding.
Well, they fund it ultimately, don't they? So it sounds like an asset management or the asset engineer would be interested because they're going to take control of the asset through handback, and they're going to see it right through to decommissioning
We,
via maintenance.
Sorry, I didn't mean to interrupt, but I think you touched on that in one of your slides in particular that I took a note on, and it is exactly what Tom's also getting to, I think, is the asset knowledge.
Mhm.
And sometimes what can be, with no disrespect to anybody, but the asset sponsor or the asset management team's experience in knowing what, and we all build in resilience, hopefully, with a project or with the maintenance, but the two have to be intrinsically linked.
Mhm.
And Tom's right, I think there is a clear boundary between the two. It would be interesting to perhaps gauge the pressure that the ORR can instill on the procurement side of things within Network Rail to ensure that the two speak to each other
Mhm.
as in layman's terms.
Mhm.
I agree with Tom. I think there's clear distinctions between everyone's trying to improve the railway, of course they are, but I think there's clear it's my ball and you're not playing sort of idea, and that still exists in large swathes of the organisation.
We have an online comment there from Jim Watson. So just it's an interesting discussion. Jim's experience is that the issue is often that projects teams will form a barrier to important discussions that should be happening between designer, contractor, and the maintainer, because the focus is about getting the project done, and if there's a detriment in the existing asset, then is it coming out of the project budget or does it come out of the maintainer's budget?
the major funder here in Scotland is Transport Scotland. And Transport Scotland go all out to ask whatever Rail considers to be awkward questions. Right? Now, Transport Scotland will say, why do I need to replace that buffer stop at this terminal station? And Network Rail will say, well, we need to, because the one that's there isn't any good. And now Transport Scotland, they say, well, you're telling me the buffer stop's not safe. Well, we operate under grandfather rights. The ORR and the RSSB don't force us to review every buffer stop, although they now do, at least annually. But the conflict is still there. You've got the people who secure the funding to deliver the project, and the people that don't secure funding but already have a budget to maintain the asset. And not one of them will stand up and say, yep, the buffer stop at Barhead is broken. And if we're going to introduce a new electric train service, you'll give us a friction buffer stop, because an energy absorbing buffer stop is the only choice. And that will shorten the platform by the length of the sliding area is 7 metres. So why should I pay for another 7 metres of platform when it's Network Rail's buffer stop that is patently wrong? Yeah, because that buffer stop was built in the 50s. So it's surviving there under grandfather rights. And the minute you introduce the change, it then forces you to consider, is the buffer stop adequate? And it all comes down to funding. And my last question was, you say we're educating people, staff, designers. Are we educating the funders into what they should be funding for? Or as Transport Scotland are trying to do, they're trying to unfund the safety aspect of the terminal station at Barhead.
So I can't speak to any specific examples, but when we are engaging, for example, in the PR23, we are giving advice to ministers, Transport Scotland and Scotland and DfT, as to what we think they should be doing. And when it comes to what's happening in CP6, Network Rail have been given a certain amount of money to do certain things and deliver on certain things. So they've got to meet certain statistics, certain efficiencies, etc., etc. And everyone's bought into that, Transport Scotland included. Transport Scotland are, for want of a better word, our client, ORR's client. They can ask Network Rail to do whatever they want, really. But if we think it falls into the brackets of it's going to impact performance, safety, or asset sustainability, then we can say,
or all three,
yeah. Then we can say, we don't recommend that happens. It's not a good idea.
What Network Rail are doing, because Transport Scotland is the funder, Network Rail are trying to meet the funder's aspirations for spend, and the funder is questioning Network Rail's existing asset, and they're saying, You run trains every day in at Barhead. Why? If there's something intrinsically wrong with the buffer stop. Well, anybody that did a buffer stop risk assessment at Barhead would find the fatalities weighted index in fatalities per 100 years would give them enough justification to spend £250,000 at least on that buffer stop. And that conflict is there, and there's a lack of education. I find there's a lack of education at Network Rail engineer level in their awareness of where railway group standards sit in the hierarchy. But some people only think of, well, Network Rail standards allow you to do this. Yeah, but the NTSN doesn't. Where is the legislation? The legislation is not in the Network Rail TRK standard. It's in an RGS, or it's in an NTSN. And because Network Rail now accept that RISs, the Rail Industry Standards are about, Network Rail now adopt them. So all this legislation, right, which eventually is underpinned by the Transport and the Health and Safety at Work Act, they don't see that. They just say, well, if I comply with what Network Rail says, we're automatically compliant. But they're not.
No, that's true.
And that is that fundamental hierarchy of standards. We've given that lecture here at PWI before. RSSB are happy to give that. But you've got to have a pair of ears to listen to.
I think that I agree with what you're saying around education and informing all parties. And, you know, my background, I'm an engineer, my background is being in working for engineering consultancies. You know, I went from being one of many engineers and the only woman to being one of many women and the only engineer, you know, and working in the civil service is very, very different. And I wanted to demonstrate as well at the start of my presentation, and I said it as well, that you know, the ORR is a very small organisation compared to Network Rail. And then if you consider that, you know, the Railway Safety Directorate look at all railways, you know, TfL, Heritage, etc. as well, we're such a tiny body. But the good news about it is that we do have the expert resources within ORR, and we are able to meet with individuals in Transport Scotland or DFT and help to inform them and explain to them some of the wider issues and themes, for example, around climate change and weather resilience is something that I've presented to Transport Scotland on. When it comes to organisations like Network Rail and TfL, and this is just my personal opinion, I do agree with you as well, that there does need to be more education and give engineers, and this is where I would go in my soapbox, give engineers more of a platform to explain what the problems are and to highlight to the project managers, the commercial side of the organisation, really what's the best option from a engineering. I'm trying to be diplomatic in my response.
To allow me to discharge my CDM obligations, I am bound to design the safest item I can. But when I design the safest item I can, and the funder and Network Rail's team says, oh, you don't need all that. No, let's not do that. Well, I think we do. So you're playing the money card versus my safety card. Who wins? The money guys always win. And that's the shame about it all, because yeah, it takes another current incident to flag up how things weren't done correctly back in the day. Back in the day was now, it would be entirely differently. And I know that the RIB investigation doesn't set out to raise prosecutions, it's learning points. But I still see the same learning points not done. We've got continual, I mean, the last mute that ran away, it did so because somebody left a safety valve open, an essential safety valve, during a service operation. So they put the mute on the track and it ran away. Oh, there's a surprise. It was on a gradient. It didn't have any braking effort. So of course it ran away. Didn't really kill anybody because the guy in the basket jumped out before it went into the tunnel. And when they found it in the tunnel, it was kind of rocking this way and that, backwards and forwards in the tunnel. But when you read, so incidents that were the same as this, There's one in 2016, one in 2018, there's one last year, and there was one 2022. There you go. That's a fairly comprehensive set of recommendations for design of on-track trolleys that have been ignored, and another incident happened, and it could have been so much worse. I mean, Carmen could have been worse if the train had not derailed over the viaduct, not gone over the viaduct, but if it had gone over onto the downline, and then a downline train had hit it, it could have been a lot worse. There was hardly anybody on the train. That was a great bonus for that, but it could have been so much worse. And nobody actually forecast the scenario, the what-if scenarios. So why would a small amount of debris derail a train? Well, because the train was doing 75 miles an hour on a curve that wasn't canted off. It derailed. It sailed over the viaduct. It killed people. And yet it takes that incident to happen before people say, well, that was unusual. Why did that train derail? I've looked at the pictures of the debris on the track, and that certainly shouldn't have been enough to derail. Oh, hang on a minute. Class 43, notoriously light in the front end, cab cantilevered right out over there. It's got a huge nose on it. It's very light in the front end. It's so light that the XPT in Australia is limited to 60 miles an hour, and the drivers complain because it goes up and down like a boat, right? And those are Class 4 UK Class 43s. They call them the XPT, not the HST. They call it some sort of express. That's what express does, but it never does any more than 60 miles an hour. So if you go from Melbourne up to Sydney, it's going to take you 8 hours, and it's not a big distance.
Should we invite some questions from the floor? If anyone's online has a query, could you raise your hand? There's none in the comments, but it may well be.
Nope.
You can open your own mic and just invite questions from the floor. We've got one here in the main room from David Maxwell.
Another one from me, Rhona, is that you talked during your presentation about keeping Network Rail on track, forgive the pun, but monitoring their continual performance from not only a safety but from a financial point of view. What's the ORR's position on the global Network Rail's performance financially between coming out of CP5 a few years ago through the CP6 period we're in now and potentially into the 23 and beyond this into CP7? What's the ORR's overall position with respect to how Network Rail are as a body performing financially?
I think the easiest way to say it, would be that they're doing all right. I mean, they are. I think we're often in these discussions, like Tom highlighted, very valid things, but we're often really prone to bringing Network Rail down because we can see so many improvements and it can be frustrating for us. But actually, Network Rail do actually a very good job overall. I can't speak to the nuances going between control periods, but I would recommend that you read the annual assessment that we produce every year. So like I said, the one for the year 21-22, we're writing right now. So of course there's a bit of a lag on it. You're not going to get real-time information, but that would be a good place for you to look to see within that year and go looking forward to the rest of the control period how Network Rail are performing. But we do every single period review Network Rail's performance in terms of volumes, so renewals volumes, refurbishment volumes and maintenance volumes, to see how they're performing against what they said they were going to do. And that's reforecast 3 times a year. So Network Rail will, so it's period 4, 8 and 11. Network Rail will reforecast their plans and move things around and say, actually, we've done more than we said that we were going to do, or we're overperformed or we're underperforming. We're going to defer things to the next year, but don't worry, it's all going to be done within the control period, or we're going to bring things forward. And if we have any concerns about it, we raise it as soon as possible, and that's where we would look to get assurance that things are actually going to be delivered. And If they're not going to be delivered, what does that mean? And would we look to take a regulatory action? And that would be looking at putting things on the escalator, etc., etc. That would get submitted to Andrew Haynes, and we would see what would happen.
Thanks.
And that's volumes and in costs as well. We look at both.
Right. Okay, thank you.
Okay, let's bring this in. Any further questions from the floor?
Tom's got a question.
No, I think he was holding his hand up to say no further questions. Right, so thank you, Rhona. Thanks for coming and testing the hybrid meeting. We've got some improvements to make this hybrid solution viable, but I'm sure we'll get it sorted for the next meeting. Just a reminder to everybody who's on the call, it's the third Wednesday of each month that we meet. So the next meeting can be a hybrid, and it'll be split between online and WSP's office at Queen Street in Glasgow, and it'll be in the third Wednesday in June. So thank you, Rhona. I think it was a very well received presentation, highlighting the importance of resilience of the whole system. A reminder to us all that minor tweaks to parts of the asset that aren't our focus do affect parts of the asset that aren't our focus. So, for instance, making small improvements to earthworks protect electrification, and also the way in which we adopt our electrification can protect our earthworks. A very fine example at the soon to be opened East Linton, Reston Station, in that and the piles supporting the platform are actually performing a role in stabilising the slopes. Yep. So there's an interface between two bits of the system. An important bit mid-presentation just about using statistical analysis, showing that asset improvement doesn't need to focus on the worst weather event, because there are other controls that we can be adopting to control the outcome of that, which means that we can focus our efforts on making improvements in resilience to the areas that matter. So not necessarily investing in asset improvements for the worst case, but focusing on where it matters. I think the suggestion was that a model is required for each instance and each project, and then that led on to a very important discussion for, I'm sure, that none of us really have the answer to that yet, but we should all, the important discussion was regarding the interfaces between asset management, maintenance and projects, and who's funding what bits. And I think Rhona's closing slides were very important, just about to enter these conversations with an open mind and enter with a spirit of collaboration to get the best outturn. Yep. It is difficult because there are people holding the purse strings, and there's a whole myriad of challenges out there. But let's collaborate with each other to get the best railway that we can. Thank you. Well, could you just all join me in thanking Rhona for coming and presenting today?
Thank you.
We can tell you for free next month, we'll get a hybrid presentation because presenters in Dublin.
Dublin, that's correct. Okay, thank you all. Have a good evening. Oh, Jim's speaking, I think. You need to unmute. Oh, yeah, he is. Sorry, Jim, we missed your